charging and discharging of condenser. You see, whenever the condenser means simply two plates at a certain distance. The plates of the condenser are never in contact with each other. Whenever the two plates of condenser are charged or connected with the cell, in that case, charging starts that for the condenser. Charging and discharging, both the processes for the condenser are exponential in nature. Exponential, E, that's given by this thing, and 1 upon E, that is equal to 0.37. This you have to remember. Exponential in nature means the processes of charging and discharging both will be given by exponential relation. The time constant is very important. That's the product of C and R, and the time taken in both the processes depend on this time constant only. Now, effective value of resistance is calculated while calculating this time constant. For that, there is one very important thing, that you just short circuit the cell given, and between the two ends of the condenser, you try out to find the total resistance. For example, here we have short circuited this cell, it becomes like this, and between the two ends of the condenser, we are trying to find out the total resistance. It's going to be R plus 3Rs, because they appear to be in series combination. Whereas here you find, again, you are going to short circuit this cell. Once you short circuit, what will happen? You short circuit, this is a single wire. Short circuit means cell is no more there. Now this whole resistance has been short circuited and not effective. So between these 2 points, only this resistance is effective. That's why I have written here that the effective resistance is R. So listen again, in order to find the value of R in time constant, what we do, we short circuit the cell first of all, and then try to find out the total resistance between the two ends of the condenser. You see, the charging process is given by this relation. The charge Q0 is maximum, and time t second after starting the whole process, charge will be given by this relation. This graph you can have here. Q0 the maximum value of charge, and this is time. You put here t equal to tau, you'll find this charge equal to 0.63 Q0. So you might say that time constant is the time after which the charge becomes 63%, about 63% of the maximum charge. Likewise, you can write regarding the discharging of the process. Discharging is also exponential and is given by the relation this Q equal to Q naught e to the power minus t upon tau. The graph would be given this way. This is Q and T. You see, if you put here T equal to tau, you'll find Q equal to Q naught upon E. That becomes 0.37 Q naught, 37% of the maximum charge. After time constant, during the discharging process, the charge is going to be this much. Half-life time for a discharging condenser, listen again, half-life time for a condenser getting discharged is the time after which the charge on it becomes half of the maximum value. And if you want to find this value, half-life time, this is going to be CR log 2 to the base E.